This is section 9.5, graph and write equations of hyperbolas. A hyperbola is the locus of all points in a plane such that the absolute value of the differences of the distance between the two foci is consistent. We have two different axes for a hyperbola. We have a transverse axis and we have a conjugate axis. The transverse axis is one of the axes of symmetry that has a length of 2a. The conjugate axis is another axis of symmetry that is perpendicular to the transverse. It passes through the center and it has a length of 2b units. Now we have two different standard forms of hyperbola again. If it opens horizontally, it's going to have your x that comes first, so it's going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. So how to tell the difference between an ellipse and a hyperbola? On an ellipse, you are adding. On a hyperbola, you will be subtracting. Another difference between ellipses and hyperbolas is on an ellipse, the a squared is always your larger value. On a hyperbola, a squared is just going to be whatever comes first. So even if the first value or the first denominator is smaller, it is still your a squared. How we decide which direction it's going to go. On an ellipse, you always put your x's first. On a hyperbola, which one goes first will determine if it opened vertically or horizontally. We have all of our lovely information again. It tells us how to find our center, our vertices, foci, transverse axis, conjugate axis, but this time we have these asymptotes. And we do have different equations to find the asymptotes. If our x comes first, or if it opens horizontally, to find our asymptote, our slope will be b over a. And to find the slope of our asymptote, if it opens vertically, the slope will be a over b. Another difference between hyperbola and ellipses, for an ellipse, c squared is equal to a squared minus b squared, but for a hyperbola, c squared is equal to a squared plus b squared. So we're going to graph the hyperbola given by the equation. We're going to identify the vertices, the foci, and the asymptotes of the hyperbola. So the first thing we're going to do is we're going to identify h, k, a, and b. Now remember, h is the value that is added or subtracted to x. And because we're not adding or subtracting anything to x, our h value is 0. K is what is added or subtracted to y. Since we have nothing with the y, we have 0. A squared is just going to be whatever comes first. So since our first denominator is 9, our a squared is 9. And if a squared is 9, that means a is 3. B squared is what comes second. Our second denominator is 25. So that means b is equal to 5. So let's first find our center. Your center is going to be your h and your k. So in this case, it's going to be 0 and 0. Next, we need to find your foci. And if we come back and we look at our rules, we can see, well, next we're going to find the vertices. We see that the vertices, because the y comes first, is going to be h and k plus or minus a. So if we find our vertices, it's going to be h and k plus or minus a. So first we're going to do h and k minus a, or 0 minus 3 gives me negative 3. And then we're going to do h and k plus a, so 0 plus 3 will give me a positive 3. To find the foci, it's going to be h and k plus or minus c. Now before we can find our value of c, we have to use our equation. And we know that c is equal to the square root of a squared plus b squared. This one is different than an ellipse. So our a squared is 9, our b squared is 25. So this means c is equal to the square root of 34. So our foci will be 0 and negative radical 34, because 0 minus radical 34 which would be negative radical 34. And then we're going to have 0 and positive radical 34. Then we're going to find our asymptotes. Our asymptotes, because this is y squared, are going to be in the form of y minus k is equal to plus or minus a over b times x minus h. So if we plug in the information that we know, we are going to have y minus 0 is equal to plus or minus a over b times x minus h. Or, because these are zeros, we can write the asymptote as y is equal to plus or minus 3/5 x. Now, when we go to graph this, you can always start at your center, which is 0, 0. You can then graph your asymptotes, or another way that I find is a little bit easier to graph these is once you have this, we're going to figure out how far out A and B should be. Because A is with the y, that tells me how many directions I'm going to go in the y direction. So if A squared is 9, A is 3. So in the y direction, I'm going to go up 3, put a dot. I'm going to go down 3 and put a dot. B is with the x. So in the x direction, I'm going to go 5. So from the center, we go 5 to the left and 5 to the right. Then we're going to create a box that goes around those points. From the box, we are now going to draw our asymptotes, and they are going to go from corner of the box to corner of the box. And this should be 5 over 3. So from here we're going, 3/5 x. So we're going up 3 over 5, and then we're drawing our line, and then we're going down 3 over 5 and drawing our line. So these should be the equations of your asymptotes. Now once you have your asymptotes drawn, this is going to open vertically. So we're going to go to the point. We're going to go to those vertices, and we're going to go towards the asymptotes, but never touch them. And then we're going to go towards the asymptotes, but not touch them. So that would be the graph for our hyperbola. Again, we're going to graph the hyperbola, identify the vertices, foci, and asymptotes. So this time our center is not at 0, 0. Remember, when you pull these out of the parentheses, you change the sign. So with the x value, when I pull that out, it's going to become -1. Our k values with the y, when I pull that out, we're going to change the sign. So we have h is -1 and k is -2. The a squared is always the first denominator. So in this case, it is 9, or a is equal to 3. And the b squared is always the second denominator, which is 16, or b is equal to 4. Now, let's start by finding our center. Our center is going to be at -1, -2. So we go over to -1, -2, we put our center. Now, I'm going to go ahead and graph this one first, and then I'm going to find all the information. So because the x goes first, we're going to take a units in the x direction. So from the center, I'm going to go 3 to the right. I'm going to go 3 to the left. B is with the y's, which is 4, so I'm going to go 4 up, and we're going to go 4 down. From there, we can create our box, and then from our box, we create our asymptote. Now, because this says the x first, we do know it's going to open horizontally, so our vertices are going to start here and here, and we are going to open horizontally. Now, let's find all those values. Our vertices, because this opens horizontally, will be h plus or minus a and k. So if I have h, which is -1, I subtract a, so -1 minus 3 gives me -4, k stays the same. Then we're going to do h plus a, so -1 plus 3 gives me 2, and -2. And if we look at our graph, this is at -4, -2, and this point is at 2, -2. To find our foci, you're going to do h plus or minus c and k, but again, first we have to find c. Remember, c is the square root of a squared plus b squared, which is going to be 9 plus 16, which is radical 25, or 5. So this is going to be -1 minus 5, which is -6 and -2, and -1 plus 5, which is going to give us 4 and -2. So if we want to graph those foci, I would have a foci here, and I would have a foci here. I am not going to require you to have the foci on your graph, though. To find our asymptotes, remember, the equations change depending on the direction that it opens. So because this opens horizontally, our equation is going to be, for our asymptotes, y minus k is equal to plus or minus b over a times x minus h. So this is going to be y plus 2, because minus negative makes it positive, plus or minus 4 over 3 times x plus 1. Now, because this isn't 0, we are actually going to have to find two different answers. For my point, we can leave it in this form, but if we did have to find the two different equations, we would have to do a -4/3 times x plus 1, and we would have to do a +4/3 times x plus 1, solve each of these separately. So if I distribute that -4/3, this will be y plus 2 is equal to -4/3 x minus 4/3, then add the 2. Or sorry, it is our positive, so I would subtract the 2. So if we subtract 2, that would give us -3 1/3. And on the other one, this will give me 4/3 x plus 4/3, or plus 1 1/3. So if I subtract the 2, that would give me -2/3, would be the equations of our two graphs, or our two asymptotes. Now, this equation is not in the correct form. We first have to get it in the correct form before we can start. Because there are only y squareds and x squareds, we don't have to do any completing the square for this one, but you do have to have it equal to 0. So the first thing we're going to do is divide everything by 100. So if we reduce that, this is going to give us y squared over 4 minus x squared over 25 is equal to 1. So we do know our h is 0, our k is 0. We know that a squared is equal to 4, so a is equal to 2, and we know that b squared is equal to 25, so b is equal to 5. So if we find our center first, which is h and k, that will just be at 0, 0. Next, if we find our vertices, because the y comes first, it's going to be h and k plus or minus a. So if we do 0 and k minus a, that'll give us -2, and 0 with k plus a will give us a +2. To find our foci, we're going to do h and k plus or minus c, but again, we have to find our c first, so it's a squared plus b squared, which is going to give us 4 plus 25, which is radical 29. So this is going to be 0, and k minus c will give us negative radical 29. And then we have 0 and k plus c will give us a positive radical 29. So it's going to be a little bit more than 5, but not up to 6. Next, we need to find our asymptotes. And because it is the y first, it's going to be y minus k is equal to plus or minus. Because the y comes first, it is going to be a over b times x minus h. So y minus 0 is equal to plus or minus 2 over 5 times x minus 0, or y is just equal to plus or minus 2/5 x. So if you want, you can just graph your equations from there. I can go up to over 5. Down to over 5 and draw my line from there. Or remember, the other way you can do this is we do know that the b value is 5, so we can go 5 in each direction from the center. We can draw our box, and then we can draw our asymptotes going from corner to corner. Because the y comes first, we do know we're going to open in the y direction. So we're going to start on our vertices and go towards the asymptotes. And we have our graph. Okay, so this time, once again, it's not in the correct form, but we do know that we can use our completing the square. To complete the square, you are first going to group the x's together. And that should be 25x squared. Plus 100x. We're going to leave a space for our y's. Minus 16y squared plus 96y is equal to 444. Now, you're not necessarily always going to have the x's first in the hyperbola. It's going to be whichever one is positive. So if your y squared was positive and your x squared was negative, then you would write your y's first. Now, to be able to complete the square, you can't have anything in front of your x squared or your y squared. So we are going to have to factor that out. So if I factor out 25, 25x squared divided by 25 leaves you with x squared, and 100x divided by 25 will leave you with 4x. On the next one, we are going to factor out a 16. So negative 16y squared divided by negative 16 will give me y squared. You are also going to do the 96 divided by a negative 16. So 96 divided by a negative 16 will give you a negative 6y. Make sure you remember that you are dividing by that negative, so it will change that sign. Now we are going to have to find the value for c on both of these. Remember, c is b over 2 squared. The b value is whatever is in front of your x or your y. So in this case, it's going to be 4 over 2 squared, which is 2 squared, or 4. So we're going to add and subtract 4. For the y, we are going to have c is equal to b over 2 squared. The b value in this case is negative 6. So we are going to add and subtract 9. Now, for the purpose of completing the square, we actually only need the positive value. We don't want that negative one in there because our perfect square trinomial is just the first three pieces. But to get that negative out of the parentheses, we are going to take the number out front and we are going to distribute it to that negative value to take it outside the parentheses. So we're still going to have the x squared plus 4x plus 4, but 25 times negative 4 is going to give us negative 100, and that's now outside the parentheses. Then we're going to have negative 16 times y squared minus 6y plus 9, and we're going to do the negative 16 times the negative 9. Negative times negative makes it a positive, and it's going to be 144. Now, to get those parts by themselves, we are going to move these to the other side. So we're going to add the 100 to both sides, subtract the 144 from both sides, and this is going to give us 25x squared plus 4x plus 4 minus 16 times y squared minus 6y plus 9 is equal to 400. Now we can factor both of these. What number multiplies to get positive 4 that adds to get positive 4? It'll be a positive 2 and a positive 2. Or remember, whatever's in the parentheses up there will go in the parentheses down here. Multiplies to get a positive 9, adds to get a negative 6. Or what's in the parentheses up here? We have the negative 3. Now the last step on your hyperbola is to get the answer to equal 1. So to do this, we are going to divide each piece by 400, and then we are going to reduce. So we have x plus 2 squared all over. 25 goes into 400 16 times, minus y minus 3 squared all over. 16 goes into 425 times is equal to 1. Now from here, we can find our h, our k, our a, and our b, and then we can graph our equation. So the value of h, remember, is with the x. When I pull it out of the parentheses, I change the sign. K is with the y. When you pull it out of the parentheses, you change your sign. A squared is just your first number. So if a squared is 16, then a is equal to 4. B squared is the second denominator, or 25, so b is equal to 5. So we do know that our center is going to be at negative 2, 3. This is where we're going to start. So we're going to start at negative 2, 3. Because the x comes first, in the x direction, we're going to move 4 units because our a value is 4. In the y direction, we're going to move 5 units. Then from there, we can create our box. From our box, remember, going from corner to corner, going through our center, we will create our asymptotes. Now, because the x comes first in our equation, we are going to open in the x direction. So we go to our vertices, we're going to get close to those asymptotes without touching them. And that would be our equation, our graph of our equation. So here's our equation, and then we have our graph. So now they're going to give us information, and we're going to have to write our equation based on the information they give us. Now, the first thing they give us are 2 foci, and then they give us 2 vertices. Just like we did with an ellipse, if you have 2 foci or 2 vertices, you can always find the center. And the center is going to be the midpoint. So I can find the midpoint of either my foci or my vertices. If we use our vertices, we're going to have negative 3 plus 3 and 0 plus 0. So that will give us a center of 0, 0, or h equals 0 and k is equal to 0. Now the distance between 2 vertices has a length of 2a. Since the zeros aren't changing, we just need to see how far it is from negative 3 to positive 3, or do the larger minus the smaller. So 2a is equal to 6, which means a is equal to 3. The distance between the foci is going to be 2c. So how far is it from -4 to +4? Larger minus the smaller. 2c is going to equal 8, or c is equal to 4. But to be able to write our equation, we have to know a and b. Remember, c squared is equal to a squared plus b squared. So 4 squared is equal to 3 squared plus b squared, or 16 is equal to 9 plus b squared. If we take the 9 to the other side, we're going to get 7 is equal to our b squared. Now, because on the vertices, it was the x's that were changing, that means the vertices are in the x directions, which means our equation will start with x first. So we have our h and our k, we have our a, and we have our b squared. Now we can write our equation. So we can write this as x minus 0 squared over 3 squared, which is 9, minus y minus k squared over b squared is equal to 1. Because our center is at 0, 0, if you would like, you can also write it in this form. Those are equivalent equations. This time, they're going to give us, once again, the vertices and the foci. So we're going to start by finding the center. Remember, we can do that by finding the midpoint. So I have -3 plus -3 over 2, and -6 plus 2 over 2. -3 plus -3 is -6 divided by 2 gives me -3, and -6 plus 2 is -4 divided by 2 is -2. So we know h is -3, k is -2. We know the distance between the two vertices is 2a. This time it is the x's, not the x's, it is the y's that are changing. So larger minus smaller, where 2a is equal to 8, which means a is equal to 4. And for the foci, it's also the y's that are changing. So larger minus the smaller, we know that c is equal to 5. Again, because of the vertices and the foci, it is the y's that are changing. On our equation, we do know that means that the y is going to come first. Now we have a, k, and h. We need to find b. Remember, c squared is equal to a squared plus b squared on a hyperbola. C squared, or 5 squared, is 25. A squared is 16. If we subtract the 16 to the other side, we're going to get 9 is equal to b squared. So we have a, we have our b squared, we have our h and our k. We can write our equation. So this is going to be y plus 2 squared all over 4 squared, which is 16, x plus 3 squared over 9 is equal to 1. This time they're going to give us the vertices and they're going to give us asymptotes. So from the vertices, the first thing we can find is our center. Again, we're just going to find the midpoint. -3 plus -9 gives us -12 divided by 2 is -6, and halfway between 0 and 0 is 0. So our h is -6, our k is 0. We also know we can find the distance of 2a. That's the distance between our vertices. So if I do larger minus the smaller, that's going to give us that the distance between those, 6 or a, is equal to 3. Now because the vertices is the x that is changing, we do know our equation. The x is going to come first. Now, if we remember back to the asymptotes, on our asymptotes, if it's the x that comes first, on our asymptote, the slope is going to be plus or minus b over a. So our slope is positive and -2. So if our slope is equal to b over a, and we know our a value is 3, we can solve for b. To get the b by itself, we are just going to multiply both sides by 3, and we're going to get 6 is equal to b. So we have a, B, H, and K. Now we can write our equation. A squared, or 3 squared, is going to give us 9. B is 6, so B squared will be 36, is equal to 1. And remember, if you want to write that y minus 0 squared as just y squared instead, that would be fine. We can also find eccentricity for hyperbolas the exact same way we found eccentricity for ellipses, so it's still going to be c over a. But remember, for an ellipse, to find c, it's a squared minus b squared, but for a hyperbola, c squared is equal to a squared plus b squared. For a hyperbola, the eccentricity will be greater than 1. So if this is our equation, we need to determine the eccentricity. Remember, the a is always going to come first. So our a value is 7. The b value always comes second, so b is equal to 6. We know that c squared is equal to a squared plus b squared, or c is just equal to a squared, the square root of a squared plus b squared. So we can say 49 plus 36, or c is equal to radical 85. So to find the eccentricity, we're just going to do c over a, or I'm going to do radical 85 over a, which is 7, and our eccentricity will be approximately 1.